to talk to you about is mainly the context in which we are conducting um, projects regarding digitization and mechanization of forest operations in Portugal. So this is not a scientific presentation. It's mainly to give you the context and present you the project that is an ongoing project and what are our main challenges within the project. So I'm working now in a Forestwise, which is a new research institution in Portugal. It was established after the large-scale wildfires in 2017 and joins efforts from the forest industry, public administration, and academia. So to tell you about forests and the forest sector in Portugal briefly, forest lands have a major importance in our country. Actually, they occupy 1/3 of the Portugal mainland, and we have three main species. We have Eucalyptus globulus, Pinus pinaster, and Quercus suber. We have other species with minor representativity, and you can see that generally we have the Pinus pinaster mainly in the north and center of the country. In the south we have Quercus suber, and we have Eucalyptus spread all over the country. And we actually have site conditions for forestry. We have annual growth of about 6 cubic meters per acre a year. So it's quite promising, and especially for the for the pine and eucalyptus plantations. And in the south, with the Quercus suber, we mainly have multifunctional forests that provide cork, but also other types of forest non-wood products. Our main difficulty when we work in forestry in Portugal is actually the social and other aspects of the work. There is actually a lack of land registry, and property fragmentation is a major issue. Actually, the forest properties have usually less than 1 acre in the northern region, as you can see in the map. And 97% of the forest land is privately owned. Some pulp companies actually own forests, but the majority of it is owned by small-scale producers. The majority of them have less than 5 acres. And we, to overcome this issue since the 90s, we have developed, we have fostered the forest owners associations. Now we have more than 177 of them spread all over the country that represents something like 500,000 of owners. These conditions are quite singular in Portugal because actually the percentage of privately owned forests in the European Union and 28 countries is around 39%. And next to Portugal, we have Norway with around 80. So this creates a lot of conditions, a lot of constraints and limitations also for forest operations. So just to tell you that we have three main value chains in Portugal. One grounded in eucalyptus plantations for mainly pulp and paper production. It's eucalyptus were installed since the 70s, and we have large vertically integrated industry groups that manage the forests and the supply chain, and things are organized regarding to eucalyptus. Regarding pinus plantations, mainly for sawmilling and panel industries, We have been experiencing a loss of forested area, especially because of the wildfires. The sawmills have been more or less uh, clustering to gain scale, and we have a strong wood panel industry group in Portugal. The cork stoppers and the cork production. We have also large scale producers. It's cork is produced where in the regions where the areas are larger, so it's more economically viable to produce the trees and explore the cork. And the cork is also has a particularity that is it can be used to produce cork stoppers, but there are a large of other applications that can be uh, um, done with cork. So it has a diversified product portfolio with a lot of satellite industries that are associated to cork transformation. We have a world leading economical group also in this sector. So this is our forests that are responsible for about 10% of the national exportations, uh, 2% of the GNP, and more than 100,000 jobs in rural areas. So besides these three main value chains, we have biomass for bioenergy growing fast in Portugal. And also we have project pilots starting this year about how to pay ecosystem services to the forest owners, also to make forest management more attractive. So in this context, forest operations and logistics are mainly performed by forest contractors, which usually work as service providers for the industry and for forest owners. May perform one only forest operations like harvesting, forwarding, but some of them also have trucks and do the transport up to the mill. Some contractors have their own yearly supply contacts with the mills, so it's a variety of business agreements that we have working on in Portugal. On top to this, the forest contractors are usually the same that perform fuel management operations. So to manage the risk of fire, there are a lot of operations to reduce forest fuel, especially close to energy infrastructures like the tower lines. So this means that every 3 to 5 years, those fuel needs to be removed, and so the same contractors that do forest operations also do those operations, and many times are the same that also do forest biomass recovery, collection and transport. So we are talking about small to medium-sized companies acting mainly locally. Uh, they have their own machinery, which is usually old, second-hand purchase from other northern countries, and there is a low level of uh, technological maturity, and the digital data is not used. So we still have a lot. We have a diversification of harvesting systems, uh, but in many cases, chainsaws and manual harvesting are still prevailing. Uh, Also, we have uh, an interesting R&D community now aggregated within the Collab Forestwise, where we have experts in forest simulation, simulators, and the development of forest management decision support tools. We are active in participating in EU projects, and so in a nutshell, this is about the context of forests and forest operations in Portugal to hopefully help you to understand what we are accomplishing in this project I'm going to talk next. So this is just a curiosity for you to see how the extraction of cork is actually done. It's manually done by experienced workers that go on top of the tree and extract those those I'm forgetting the name in English, branches, I don't know, those parts of the bark that will then be boiled and processed until cork stoppers are made. Okay, so now jumping into the replant project, which is the core of my talk today. This project, it's a large-scale project funded by the Portuguese government, and it will develop research and innovation in three main areas: forest and fire management, risk management, and circular economy and value chains. It has 20 co-promoter entities and is headed by the Navigator company and Forestwise. I'm going to talk to you specifically about the developments we are doing regarding circular economy and value chains, whose outcomes are mainly thought to be used by the forest companies and the forest service providers that I've been telling you before. This is our website of the project Replant, where you can find more information, but I'm also available for further information if you need. So jumping now about the specifics of what we are trying to accomplish with the digitalization of harvesting and forwarding operations. Actually, what we want is to be able to automatically collect and transmit information to remotely monitor the execution of forest operations. This will allow us to analyze and share relevant information to support planning and decision making of various stakeholders. And the consequence of this is, of course, to be able to increase the sustainability and efficiency of forest operations, and furthermore, create conditions for the adoption of forest automated solutions to overcome the lack of manpower that we have been experiencing in forest operations in Portugal. So for accomplishing this, we draw a set of KPIs that will allow us to monitor the different dimensions of the forest operations execution. Like we want to be able to monitor what is actually being done, which operations, how long do they take. So these are KPIs related to operations productivity, but we also want to be able to monitor the forest production. So how much wood is being produced and where. Then we want to be able to use this information to do better planning of the logistics and the supply chains, mainly to be able to control the workflows from the forests to the mills, and with this to be more efficient, specifically regarding to wood storage and transport. Then we want to be able to also collect information that can be valuable for the maintenance of the forest machinery, and also to be able to do sustainability assessment of the overall forest operations. So this is the overall goal, what we want to achieve. The way we are achieving this is by developing and integrating a set of devices and tools that will be working together. So the first is devices in the harvesters and harvesting equipments. to be able to collect some of these relevant indicators about the operations and the forest production. Then also devices in the forwarders to be able to track the wood movements. So in connection with the harvesters from the harvesting to the roadside. We also want to be able to include solutions for being able to measure the whole roadside piles of logs, but also of wood chips and forest residues. And based on these data collection devices, we want to be able to feed an advanced planning system with a monitoring dashboard and decision support features that will be able to analyze all the information collected and share it with relevant stakeholders. Um, this solution that we are advising uh, should be scalable to be able to later be integrated with forest planning systems like the INFLOR, currently used in several pulp and paper companies for forest management and planning, and further be extended to collect, integrate data, track and trace data from wood transport. So these two aspects, integration with planning systems and the transport, are not currently covered in our project. Only the harvesting, forwarding, and files, and bringing the information up to the dashboard. So
Alexandra,
this,
four
yes,
minutes left.
okay, thank you. So for this, we are using Stanford 2010 as a standard for interoperability between the devices. We are thinking now on implementing the first files regarding production reporting that will enable us to get the location of the equipments, also the volumes that are being harvested and forwarded. And also we wish to include here some additional KPIs like fuel consumption, which are not off the shelf in the Stanford D, but are relevant for our stakeholders. Next steps, we are thinking on including the other types of files that are covered in Stanford D 2010. For this, we are developing one of the key devices we are developing is a device to be able to couple in the harvesting and forwarding equipments. To be able to design that equipment, we did a survey with forest companies and equipment sellers to understand what were the equipments used in Portugal. These are the results. And based with that, we understood that we had a best case and worst case scenario. The best case scenario is for the machineries that are over 2010, which already have Stanford enabled. So what we need to develop there is a solution to retrieve the files, add the additional KPIs, and do data consolidation and connection. The worst case is for the machineries without this enabler, including excavators with failing heads, which are widely used in Portugal, where in this case we need to develop a completely new device with sensors for collecting data, because we are not able to use the machinery sensors that are already included there. So this is an image of the device that we are developing here. Several sensors and informations that it will retrieve to fill the Stanford format. I will I will move a bit forward faster because of the time. Um, this is to tell you about the advanced planning system we are developing. Mainly, this advanced planning system has a common user home with maps and dashboards, from which you can either use functionalities related with forest operations planning as a common DSS, decision support system, or you can visualize and monitor the data collected by DOT interoperability devices, which will be in the form of a set of dashboards that are being designed with the stakeholders. What we want to achieve also is based on the current situation captured in the dashboards to be able to trigger manual or automatical replanning of the forest operations. So you have here the video of the demo for what is being done with this advanced planning system called Forescope. Now, briefly to tell you about the mechanization of forest operations. What we want to achieve is to be able to adapt forest machinery to specific harvesting conditions in Portugal, like the slope and small parcels, and be able to do it in a multi-purpose way. So the same machines can perform complementary operations like site preparation and fertilization. With this, we also want to increase efficiency and sustainability of the operations. So we have been developing for this multi-purpose equipment coupled with a tractor, which will be able to collect data and provide it in a Stand4D format, and later integrate with other solutions in the constellation I've shown you before of the tech of the IoT platform. This is just to provide you an example of this multi-purpose equipment being designed in this project. It has, well, we have a Fravizel company doing the mechanical design to be able to adjust the fertilization capacity, to be able to do variable rate fertilization. Also, the discs and the rip for doing soil preparation, and to be able to be side adjustment so the machinery can be flexible to cover the soil with the slopes and so on. So I finish with just showing you a simple demo of the machinery working already in our prototype conditions. Okay, so next steps. We are concluding the prototypes of these different solutions. Next year, we will work hardly on the integration and interoperability, and then we'll do demonstration in field tests. So we have a lot of field demonstrations going on and planned until the end of the project with the stakeholders, particularly the forest industry and service providers, to adjust these solutions for their needs. So this is all. Thank you very much for your time.
Thank you, Alexandra, for your presentation and for being quite sharp on the time schedule. We do have some questions for you on the chat box right now, but we will do all the questions addressed to each speaker at the very end of our presentations, okay? So thank you once again. And I would like to kindly invite Bill Cronley to bring his presentation to us. Bill Cronley is working on automation in mining operation in Canada for Hardline Company. He's the Latin American sales manager with more than 20 years in mining and energy industry experience. He has been working in innovation and technology areas in Middle East, Asia, North and South America. So please, Bill, be welcome to join us and to do your presentation, and you can pop up as soon as you're ready to us.
Perfect. Thank you very much. Thank you for the introduction. I'd like to thank Angelo for inviting me to this event, and thank you everyone for attending. I'm just going to share my screen here. Sorry. Can you see my screen?
Yes, perfect. And it's in a full mode screen.
Okay, great. Okay, as I was introduced, I work for a company called Hardline Solutions. We're based out of Canada. I'm currently in Bogota, Colombia. We've been, let me see here, I'll just go on here. We've been in operation since 1996. This is our main production facility in Dowling, Ontario, which is just north of Sudbury. So we have the production facility in Sudbury, Ontario. We have our new research and development technology center in downtown Sudbury, Ontario. We also have physical offices in Santiago, Chile, Salt Lake City, Utah, Lima, Peru. And we have distributors all over the world, all throughout Latin America and through Asia, Australia. So we're represented globally. So Hardline Solutions, they're a company, you know, like I said, they've been around since 1996 in Sudbury, and they're very active in the community in Sudbury. So our owner and founder here, Walter, oh, sorry, he started the company, and he sponsors a course at the Sudbury Laurentian University. So they're very, very strong in the community, trying to promote automation into the mining industry. So Hardline is a company where we do everything internally. We do all the research, design, development, and manufacturing in-house. So 95% of our products are made at our production facility in Sudbury. And then this helps us be very competitive in the mining industry. So we're not waiting for materials that are coming from third parties and whatnot. So service as well, we're a company, we do all our installation, training, maintenance, support for 365 days a year. We train, we do certain master service agreements with all the companies we're involved with, so that their personnel are quite trained in troubleshooting our equipment and maintaining it themselves. So one thing about Hardline that makes us unique is that we can take any piece of equipment, any machine, make, model, year, and we can make it either radio remote control or teleoperation. So we've done over between 3,000 to 4,000, somewhere around 3,500 different machines into radio remote control or Teleop. And I'll get into a little bit as to what Teleop encompasses. This is a suite of our products. Like I said, most of this is, well, it is all engineered towards the mining industry. And I'll get into, at the end of the presentation, I'll get into how we came into this presentation today. So this is our flagship product, or this is the product we started with in 1996. It was just a basic radio remote control, brand agnostic. We basically our main product that we've been running with this is the underground LHDs, the loaders. And it, like I said, is brand agnostic, so we can have one radio remote control, which we can program it to run any brand, Komatsu, Sandvik. It doesn't really matter. It's brand agnostic. This is the same piece of equipment, radio remote control, but we have a video screen, so the operator can be farther away from any areas that might be a danger. So we would put a video screen on his remote control, and then we would also implant cameras on the machinery, so he can be, like I said, farther away. We're actually looking into implementing something like this, maybe in Brazil, in the forestry industry. We also develop our own network. We have just, we would connect to whatever the mine's internet framework is, whether it's LTE, Wi-Fi, it could be fiber optic, and then we would spread it out. We have a quick system. It's plug and play system that we can just connect cables that are less than 20 volts and we can spread it out throughout the mine, so we have coverage through all the areas, which is right now we're seeing is going to be one of our main challenges in the forestry industry is if we want to implement teleoperation, is getting the network coverage over the areas. But it's something that's coming up for sure. So this is our Teleop product. And after this presentation, I'll show you a 3-minute video so you can get a better understanding of exactly what we do. So we remove the operator from the the noisy trucks, loaders, or whatever situation, and put them in a climate controlled, comfortable environment, sitting in the same kind of chair they would as if they're operating a truck or a dozer or whatever piece of equipment. The operator, actually, we have been implementing this for a lot of people who are on light duty, who have been injured at work, and they can't go down into a mine, so they can come to a control center and operate their equipment from a comfortable environment. So I'll get into this. So basically, this shows, in this illustration, we show a control center up here, and from that control center, we can operate different types of equipment, and we could actually operate that. We could operate all of these different types of equipment from one chair if we wanted to. So our basic teleop system is a 1-to-1 teleop. So you have one chair, one operator operating one piece of equipment. So basically, you see him sitting here. He has the same controls as he would in the machine he's going to be operating. You have we have 2 cameras, front and rear, or we can put as many as they need. If there's a reduced visibility area, we can install another camera. And then down here, you would have a touch screen, which can show whatever you need. This will show the map of the mine. It can show diagnostics of the machine. And then you can also switch from here. I'll show you that later, but he can switch to different machines as well. And as well, up here on the video screen, you have outputs from the machine you're operating. Temperature, fuel, and anything that you need to output it from the machine. You would see normally on a day-to-day basis. You would also see this on your output screen here. So this is our other one. As I mentioned, this is Teleop Multi. So you have one operator, and they can operate. It's unlimited the amount of machines we can operate from this chair. So she's sitting here, she can see the map of the mine, but she can also select whatever machine she's going to operate. When she selects, or when you select from one machine to the other, the previous machine you've been operating, the machine you're operating will go into a safe mode, and then you'll operate one at a time. So you select this machine, all these other ones will be sitting in standby until you select it, and then the other machine will go into a safe mode. That's on your basic multi. As you can see here, she's selecting different types of machines and to whatever one she wants to operate. So also though on this multi, so this is our basic multi, but we also have Teleop Multi, which is auto. Oh, sorry. And so we have semi-auto and auto. So basically, if we have a semi-auto function on this chair and you're running it in multi, you can operate, for example, a loader. And then once it's loaded, you can push a button and it'll drive to the unload point. And then while it's doing that, you can operate a different machine. So it's got some autonomous features. And our next step is to be 100% autonomous. We've implemented, right now we've done, we're in a mine in Chile, and it's going to be our flag. It's going to be our main project right now. It's going to be 100% autonomous mine. So we've been implementing our new technology into the operation of loaders in this mine. So that's where the technology is advancing to that stage where we want to be 100% autonomous. Like I said, here's where she can select from one machine to the other. So this is just case studies, for example, and I'm going to show you this video. This is a mine we did in Chile, where we did a pilot project for them. We installed 7 systems into trucks, shovels, and a loader. I'll show you this video. It's in Spanish, but you'll get the idea of it. It's good to see what the operation is. This is another teleop system we did where it was a demolitions cleanup. So we set an excavator, we put a teleop system on a excavator and operated it 1 kilometer from the site to safely clean up the environment of any explosives or whatnot. I'm just gonna, the other is just, these are a couple of pieces of equipment that we make internally at Hardline, low profile loaders. But anyway, so I'm just going to, it's a quick presentation, but I'm going to show you the video. Can I share sound on this? I think I am. Can everybody see this and hear it?
Yes, Bill.
Okay. Okay, this is in Spanish. I'll just let it run through, but and then I can explain if, a little bit at the end.
Históricamente nosotros hemos explotado las minas en función de las tecnologías que están disponibles en el mercado. Este no es el caso. Nosotros queremos aplicar tecnología de acuerdo al comportamiento que tenga el macizo rocoso de nuestros materiales. Lo estamos mirando al revés. El cerro manda. Este es el desafío. Aplicar los taludes verticales con operación remota a una mina que está en una condición de cierre. Incorpora un concepto técnico en el diseño minero, pero lo más importante en la adaptación de la gente al cambio que estamos provocando.
Las minas a rajo abierto se explotan con un diseño de taludes o paredes de hasta 18 metros de altura que van formando terrazas similares a un anfiteatro. El nuevo diseño de talud es ahora una sola gran pared vertical de 52 metros de altura. Luego que se realizan las tronaduras que fragmentan la roca, ingresa la pala que carga los camiones con el mineral para transportarlo a la siguiente etapa. De esta manera se extrae mayor cantidad de mineral y menor cantidad de material estéril. La faena se torna más productiva y con menores costos de producción. El operador visualiza las condiciones de terreno a través de un sistema de cámaras de video, como si estuviese operando desde la cabina de la pala, de los camiones o los demás equipos, alejado de la zona de riesgo, operando los equipos a distancia mediante la teleoperación. La estabilidad de esta gran pared es fundamental para la seguridad del yacimiento y para el plan de producción. Un radar monitorea milimétricamente el talud en tiempo real, detectando inestabilidades y movimientos para adelantarse a cualquier incidente. El equipo está diseñado para resistir las condiciones más adversas y monitorear las 24 horas al día, los 365 días del año.
Hay lugares en que la naturaleza tiene paredes verticales de gran envergadura. Por lo tanto, estos diseños de taludes es porque estamos volando la naturaleza. Componente importante de este proyecto es no exponer la gente. Hemos desarrollado e incorporado la tecnología de la operación remota telecomandada. Es una tecnología que está disponible en el mercado, pero la bondad que tiene este proyecto es que la integró. Debe ser la primera mina en el mundo que tiene una operación remota telecomandada en la operación que estamos viendo. Ambos equipos, hoy día 24 de diciembre, están trabajándose en forma remota telecomandada.
24 de diciembre, la fecha de cumpleaños, y quería hacerme un regalo.
Ese es nuestro módulo de operación remota, OMOR.
Y mientras mis compañeros estaban operando los equipos acá, yo salí con mi teléfono celular y quise hacer una grabación de lo que ellos estaban haciendo, de lo que yo también estaba haciendo.
Esto, para que ustedes tengan en cuenta, va a cambiar totalmente lo que es la extracción de mineral en minas a rajo abierto en el mundo.
Gracias a esta cámara podemos ver todo lo que está pasando dentro del mismo equipo, si estuviéramos sentados dentro de la cabina.
lo que es presión de aceite, temperatura motor. Esto para nosotros es como venir a jugar acá con los camiones hoy en día. Aquí este es mi nuevo camión. Yo tengo las mismas funciones que tengo en el camión cuando lo operaba de forma manual. Puedo dirigirme hacia cualquier lado, tengo los pedales de freno, tengo toda mi comodidad, la misma que venía en el camión físicamente allá.
No es lo mismo estar en la cabina del camión que estar acá. Y va a ser una ganancia tanto para el país, para nosotros y para todas las personas que están acá, porque la calidad de vida es un cambio muy diferente. Vamos a cambiar el curso de la historia de la minería, en la extracción minera. Es algo espectacular.
Este es el punto de inflexión de la minería antigua a la nueva minería que se nos viene.
Esta es la minería del futuro.
So,
Bill?
yes, sir.
Yes, you have 5 minutes left.
Okay, so basically, as I was saying, so as you can see the technology, we're at this stage right now where we're working with a couple different companies within Brazil and Chile to see where we can implement this new technology into the forestry industry. We have our own internal software called an Emerald system, where we can monitor certain outputs of each machinery that we're controlling by teleoperation. So this would help giving you detailed reports as to, well, we're doing it right now for bucket counts, operation time, downtime, stuff like that. So this will help in increasing production and reducing downtime. So basically, yeah, like I said, we're at the beginning stages right now of implementing this technology into the mining industry, or into the forestry industry, sorry. But we see really great opportunities, and we hope to advance in it very soon. But thank you for your time, and I hope to speak to some of you guys very, very soon in the future here about some of these opportunities.
Okay, thank you, Bill, for being very precise on time and also actually ahead of the time. And the questions will pop up here on the chat box. So please, the audience, feel free to shoot questions to Alexandra and Bill so far. And now I would like to invite for the last presentation of the day, Wim van der Meijden. He's from the IUFRO Group in Netherlands. He's the co-owner of this group, and he's responsible for the new developments and sales. His technical background is in machine building, and he was employed in the food industry back in 2008. From 2016 on, he joined the agricultural business to bring the high industrial standards of the food industry into the agri or maybe even forestry world. Okay, so be welcome, Wim, to our presentation, and feel free to use your 20 minutes from now on.
Thank you, Saulo, for the introduction. Also, thank you, Angelo, for the invitation. I will share my screen. Wait a second. Hopefully everyone can see in full screen now.
Yes, it's on the screen right now.
Good. Yeah, I have a little presentation now about automation in the professional forest industry, and it's more what we do as IUFRO Group. So a little introduction of IUFRO Group, what we do, importance of robotics, the combination of robotics and 3D vision technology, and some use cases. I have some videos in it, so I will go quite fast through all the theory and will show you some videos. Maybe that's more interesting. Yeah, a little introduction. I'm Wim van der Meijden, Bachelor of Machine Engineering, 44 years old, co-owner of IUFRO Group, and a lot of experience in the machine building industry. Introduction of IUFRO Group. IUFRO Group makes industrial technology applicable for the horticulture sector. The focus of IUFRO Group is to automate difficult labor processes in the horticultural industry by using vision technology, and especially the AI vision technology and robotics. We were founded in 2002. In principle, we do all in-house, so we have our own R&D center. About 15 or 17 people are working on R&D. In total, we have 70 plus employees located in the Netherlands, in the center of the Netherlands, and we operate worldwide. We have currently about 750 machines operating in field, and worldwide is mostly Europe and North America, but also Japan, Australia, Brazil. Our professionalism is the automation in the professional agri industry, using of robotics, AI vision technology. This technology will support consistent data-driven breeding, so it helps the grower with breeding, and also saving labor costs and avoid human mistakes. But you can see more and more the use of data. With our vision systems, we generate a lot of data of all the products, and it's more and more used by the breeding process. Overall, worldwide, 87% of all AI projects will fail. And why? A lot of crappy concepts, or concept cars. What you see, the proof of concept is mostly quite easy. Our team is focused on the proof of concept, but to transform a proof of concept to a commercial product is quite hard, especially in the agri and food, because the complexity of the product. Automation is challenging, and that's just the core business of ISO. We automate all the processes, and the key focus of the key points are keep it simple, make it flexible, as little as possible parts, and it should be easy to use, because also the operators has to work with this kind of technology. What we do in our business is see the plant, judge the plant, and bring the plant where it should go to. So that is what we will do with our AI vision system. We have what we use in most of our machines is a multi-camera setup that we are looking with multiple cameras, 6, 7, 8, a little bit dependent of the complexity of the product. We'll look to the product, we'll generate a 3D model, so we have an exact model of the plant, and then we can judge the plant, and it's all based on artificial intelligence. You can see some pictures of a plant. It will be transformed in a full 3D model, and with this model, a little bit depending if you use black-white camera or RGB cameras, you can see a lot of characteristics of the plant. And that's also for, in this case, for the eucalyptus, what we can see, we can of course measure all the dimensions of the plant. We can the height, but also diseases on the leaves, the remarks on the leaves, etc. We can detect it. And how is that done? It's the software behind. It's a model creation software, so the user can make their own model. And that is, I think, one of the unique selling points of our products, that the user can create their own model. And that is done by 2D labeling tools, but also with 3D labeling tools. And it's quite easy. In, let's say, 10 to 30 minutes, you can create your own model. And that's especially in the agri products, because there is a lot of diversity in the products. It's yeah, the unique selling point for this. You can see an example of 3D annotation tooling. So in this case, we have a branch or a bulb that you can annotate. With this technology, you can build your own model. These are all the labeling tools that are behind, and you can use it. And the benefit of this one is that all the data is collected. You can label, annotate your own data and train your pipeline. So it's also during the time the efficiency will increase, but also the data, you can use this data for breeding purposes. We have here also some use cases for what I want to show to you. In this case, it's a planting robot. There we stick loose cuttings, unrooted cuttings, into the soil, and with this kind of robot we can stick a lot of different crops, and all the models are trained by the people itself. So you are quite flexible. You can change over within seconds to another variety. On the bottom you can see the eucalyptus cutting, what we have done to stick them into the soil to root. And the benefit of this is that we can, in principle, we can also make a pre-selection. We can select on diseases, on leaf sizes. So it's all about generating data and make decisions. In this type of machines, we have hundreds of them operating in all over the world. Low-skilled operators are able to run, but also to make their own models. And the benefit of this type of machines, we can put multiple in parallel, so you can handle different kinds of crops at the same time. In principle, this technology, this is 2D technology. So we are looking with several cameras to the product, but it's based on 2D. In the next slides, you can see more 3D applications. this case, or in this slide, there's an example how to annotate rose branches. You can see in the on the right side of the screen, there you can see all the 2D images. It's transformed into a 3D model. And while annotating, you can check if all stems are annotated. So you, as an operator, you can easily check if the created model will be sufficient. Here we have the use case about the rose cutting machine. And what we do is if the rose branch is annotated, we have generated the model. An operator has to bring in the branch into the machine. It's placed in a carousel. The carousel will move the branch into the machine. We are looking with 8 cameras to the branch, and then we will create the 3D model and calculate how many cuttings we can cut from this branch. And a robot unit will cut the cutting from the branch and stick them directly into the pot. And the benefit of this is that you have all the fresh cut, and also the cutting is exactly the same, and that helps the grower in making uniform plants. And also to avoid diseases, because no humans are involved in the cutting, making the cutting. And all this software is based on AI. So to transform or to change over to different kinds of crops, you can make your new model, and within 1 hour you can run another crop. And what you see is that are all AI-based projects, and I think one of the strengths of ISO is that we are able to transform a proof of concept, to transform a prototype into commercial machines who can run all over the world without direct support from us. Of course, we do the service, but yeah, there are running hundreds of them in all over the world. This use case is planting of tulip bulbs. So in this case, we separate the bulb. We are looking with 6 cameras to the bulb, how we can orientate them, but also if it is a healthy bulb or a bulb with diseases. And the bulb with diseases, we will skip them, and all the healthy bulbs will be placed in a system and then put them in the crate. This is also an example of AI vision system in combination with robotics. So 4 robots are picking during the movement the bulb from the belt. We rotate them in the right direction, because we have to put the bulb in a certain way into the crate.
When you still have 5 minutes.
Yep. Thank you. Another use case of our platform, because it's in principle more a generic platform, and we can use it for sticking cuttings. You can use it for planting burdops or for cutting from the rose branch or different crops. But also this platform we can use it for sorting, and that's especially for plants, diseases on leaves, pairs of leaves, bending of the stem, the amount of stems in a pot. It's all about how to train the model. You can see a little bit how we do that. We separate the plant. We put the plant in a chain. We separate them on this part. Then we are looking with multiple cameras. And the benefit of these systems are in comparing to others, that we are looking with multiple cameras. So the product is not rotating. It's very stable in a certain position. So we can create a very, very accurate model. Here the leaves are counted, the surface, roots. We can measure the roots. Here we have a use case that we measure on multiple aspects of the plant. And this machine, for example, can do 8,000 plants an hour. Here we grade the plants in different grades, and each machine is built up as a modular system. So we can grade it into 3 sortings, but also in 4 or 5. It's what is needed. And the robots are collecting all the plants at the right grade. And the benefit of this kind of systems is comparing to other systems that it's all based on AI. So you can train and retrain the model. And that's also, there is a continuous development in this platform. That's a little bit what we do as IUFRO Group and how we enter the market, and also how we try to enter the market of the eucalyptus and the pine trees. We are very, very familiar in the horticulture, and now we are in the first stage entering the eucalyptus and the pine tree. Yeah, that's it.
Okay, thank you. Thank you, Wim. Thank you for the presentation. Yeah, we can see you. Yeah, we can see you back. Okay, thank you for the audience today. We had at the beginning close to 78, 80 people watching this presentation. So far, we still have 62, 63 people on board. So thanks for staying with us all the time. Can you see my screen right now?
Yes.
Yeah. Okay, thank you, Angelo. So I would like to address some questions to you, speakers. So we have many questions from Angelo, from Miguel Pellegrin, from West Rock, Brazil, from from Ulla Lindros from SLU, Sweden, from Marcus Vicker, Stora Enzo, from Carola Hagstrom from SLU, from Woodenchan, Oregon University, Claudinei Quinto, Bracel, São Paulo. And the first question that I would like to bring to you, Alexandra, is from Miguel Pellegrin, West Rock, Brazil. And he would like to know how can, what have you done actually to access the Stand4D, and what kind of gadget or technology data you transfer from this device or this technology? What was the way? And also, there's another question from Ola Lindro on the same way, on the same technology. Are there some Stand4D data that are considered sensitive to collect and that therefore have been left out? Those are two questions firstly addressed to you, Alexandra.
Okay, Saulo, thank you for the questions. Actually, regarding which type of Stand4D data we are using, we are mainly focusing on the more basic files, the HPR, and related with the harvesting volume. So we are wanting to know for each log the length, the diameter, number of trees, species, and we also want to know the location of the logs and also the equipment. These are the basic information. On top of that, we want to have some additional KPIs which are not yet included in Stand4D for what, according to our knowledge. For example, fuel consumption, which is important for equipment machinery, for machinery maintenance, and also for sustainability assessments. So actually we did the process two ways. One was to ask the stakeholders what they wanted to have. The second one was to see what was available in Stand4D, and then we did a match and understood what were our basic requirements for the solution so far, knowing that this will be a progressive development and further features will be included later.
Okay, just to conclude the last question to you, Alexandra, from Marco Vicker from Stora Enzo. He would like to know how the information from the machines could be transferred to the database, and also if you have coverage in all areas with mobile phone signal.
Yeah, that's a good question. No, we don't have connectivity in the forests today. There are several projects also going in that direction, but not the reality now. So it's a requirement that the device should be able to be locally downloaded. So you should plug in the machinery to extract the data. That is a requirement. Also, the machinery needs to be able to manage the data, to know which data was already extracted and which was not. So doing the internal data management within the device, that's also a requirement. We are interacting with telecommunication companies, and it is possible that we can have connectivity even if there is no connectivity for mobile phones available for commercial uses, but that's still in the infancy, all those contacts. So we are working in a scenario now where connectivity is not a reality.
I see. It's the same situation for sure here in Brazil, and I'm not quite sure about the other countries. Maybe they have more technology, like in Sweden or United States, but again, it's still a problem. We have a few questions for Bill. One is from Angelo. If you know, Bill, what is the maximum distance for teleoperation in forestry, not in mining? And also from Marco Vicker, if the autonomous machine, fully autonomous machine, is a go for the mine industry, or this is not the focus, and the main focus could be remote operation. And just to bring more questions to you, Bill, at the same time, you mentioned that there's a possibility for each operator to handle multi-machines. So how soon this could be implemented, and why is this possibility is not used today? And this question was addressed from Carola Hagstrom from SLU.
Okay. So as far as distance, like I said, we have not implemented anything in the forestry industry at this point, but for example, the communication system will be the exact same that we would use in the mining industry. And distance is not a limit for us. What our limit is, our limiting factor is the network. For example, we've operated equipment in an underground mine in Sudbury, Ontario from Australia. So there is no limitation on distance. If we have network, the proper connection, the requirements for our network for the video transmission and whatnot, there is no limitation. We have a mine in Thunder Bay, Ontario, Canada, where they made a command center in the city of Thunder Bay, and the mine is at a remote location 400 kilometers north, and it's a fly-in mine. So they have their operators just come to that command center in Thunder Bay. So they're saving on flights, accommodations, and whatnot, and plus the danger of people going underground, right? So for the distance, that's not, the distance isn't the limiting factor. The limiting factor is the communication, the network. The next one, autonomous machines. So autonomous is where the industry wants to go. I'll be honest with you, the main limit, the main pullback from that is eliminating jobs for personnel. So that's why, for example, we do autonomous in situations where it makes sense. For example, a rock breaker. If a rock falls on a screen and it's too large to go through, you have to put an operator there just to break that rock until it falls through. And he might only operate out of a 12-hour shift. He might only work 1 hour. And there might be 15 rock breakers throughout the mine. So right now, we've just done that. We've made an autonomous rock breaker. So if an object falls on a screen that's too large to fall through, the machine will automatically break the rock. So because those operators, that's usually not their full job. They're also doing another job. So this is just helping them with their production time, and it keeps their operator focused on his main job. So autonomous is going to be focused where it's most makes more sense, right? Because we don't want to eliminate jobs, etc. So Teleop is the best situation because you have a camera, the operator sees what's going on, and then if you put some semi-autonomous functions on there so it doesn't bang into walls, stuff like that, we find that's been the most popular alternative for mines.
Okay, and Bill, there's another question before you move ahead from Professor Wooden Chan from Oregon University. Do you have experienced any difficulty in workforce training for remote operation? And also, is there any difference on their work efficiency when you compare the remote operation and non-remote operation?
Well, actually, quite the opposite. A lot of most of the people just love this technology. It's like playing a video game, right? So they like the work. It's, you know, they get into a chair, they're operating the same equipment, and you know, it's really quiet. It's just like a video game. So we don't get any pushback from the operators or complaints. So they really like the technology. Work efficiency increases. We have a mine where we did a case study. It increased by approximately anywhere between 15 to 25% of production time, work efficiency, because you're eliminating shift changes where the operators are going down in an elevator. They might take 2 hours, an hour and a half for lunch, or an hour for lunch, but they have to walk to a lunchroom from their equipment underground. And you're eliminating all this time, right? If he's operating his equipment right from the trailer, you know, your lunch is right there. You don't have to go far for the restroom or whatnot. So no, we find work efficiency actually increases quite a bit.
Okay, thank you, Bill. I should move forward to the next speaker and some questions, Bill, because we are running ahead of time. So my next question will go for Wim, and the question was addressed from Ula Lindros from SLU, and he, like me, we were impressed with your technology and how the machines can handle so fragile materials in the nursery. So the question is, if you have the survival rate or any other quantitative or qualitative outcome from the automated planting compared to manual planting, and to address another question from Claudinei Quinto, Bracel, São Paulo, Brazil. What is your strategy to offer this technology and it become available and feasible in countries like Brazil, Indonesia, India, Africa, where we have strong forest business going on right now?
Thank you. Yeah, about the handling of fragile material, the success rate. Yeah, if you put, it's also, it is always a little bit dependent how fragile it is. But what you see that with our special developed grippers, they are patented grippers, that how more fragile the plant is, how better the result. And that is, it's a little bit strange, but what we do, we take the cutting at the end of the stem and we drag them into the soil. So we don't push them. So what you're comparing to manual handling, and human will press the cutting into the soil, and sometimes then the stem will bend or break. And with the machine, we will drag the cutting into the soil. So what we see, that if we put a plant into the soil, that our success rate will be over 99%. And our strategy to become the technology feasible in countries like Brazil or Indonesia is, we are looking for partnerships with our customers. It's especially for the forest industry. It's not a standard machine. It's not on the shelf right now. So we are looking for partners who knows what they want, but also are willing to put time, energy, etc. into this project to make it fully successful. I see also the question from Marcos, because we have one machine at this moment at Fibria, or it's now Suzano. And the question is, if I am happy with the results, and no, I'm not happy with the result, because that machine was implemented, I think, 3 years ago in 2016, so almost 5 years ago. And it's one of the first machines in the forest. And we learned a lot of that. And it was a test machine. But yeah, we have now improved our gripper technology, but also the separating of the cutting. So to be honest, no, we are not happy with the result, but we have learned a lot. We have improved the technology. So I'm confident that we have a much better solution, and we are now looking for customers who want to adapt the partnership with ISO Group.
And this also includes in your strategy plan Brazil, Africa, Indonesia, and growing countries like us. Is that right?
Yeah, that's right. Yeah. Yeah.
Okay, thank you for replying to questions and address the Marcos Vicker last comment and questions to you on your reply. So, gentlemen, I would like to give the floor to Angelo Moura, but before I give the speech to him, I would gently thank you all for being with us during this an hour and a half for questions. Unfortunately, we were not able to provide all the questions for the speakers, but you can be connected with them through IUFRO. So thanks for joining us this first meeting. And Angelo, I'll give you the floor for moving on.
Hello, everyone. Thank you once again for your time and for being joined with us until the end, the very end. Thank you for all the audience, the speakers, of your great presentations. It was very nice to see the advances and the technology that's put in practice. And I would like to give you an invitation. I don't want to take too much of your time. I'm trying to share my screen, but I couldn't now, but I would like to invite you for the next two seminars. We'll have one in September with the guys from New Zealand and also Brazil. There will be Paul Milliken and Professor Rian Visser from New Zealand, talking about harvesting and teleoperation in New Zealand, some advances they are having there. Also, Marx from Cytex, a Caterpillar company, talking about mining operations. In the last seminar in October will be addressed by Sweden, mainly from Professor Ola, that is here with us from SLU, talking about developments, advances in harvesting operation. Also, the guys from Combitex, a company with advances in teleoperation and full operation in different sectors like ports and also autonomous cars. And for the last but not least, Professor Saul again, closing our series with talking about the eucalyptus plant machines. So you can join using registering using the form that is in the IUFRO official page calendar and also in the LinkedIn. And just a final word, thinking here about what is the motivation to talk about automation. It was addressed some questions, concerns here today. And just to summarize, if you think quickly, there is a lack of hand labor for the near future. I think not just for developed countries, but in many countries you will face that with changes in different deadlines for each one. We have nowadays advanced with AI in many areas, and also we have some potential to reduce variation in our operations. But we have all this combination of factors, motivation factors, but also some issues. You can see that Bill and also Wayne had many advances, but we still have some issues. Integration, amount of data, connectivity is not something easy, mainly if you think in hard environment as we have in forestry. Also mining has some difficulties, but so that's the purpose to have this talk here today, trying to combine industry and academy, creating opportunity, matching people, and through IUFRO is an international organization to do that with many experts, researchers, professors, and all the industry together, try to move forward with this aspect. And one important thing is that thinking in technology roadmap, innovation is done step by step. So when you think from teleoperation, partial operation, and full autonomous, makes completely sense because we cannot imagine to have from overnight an autonomous operation, mainly in forestry. So that's, I think, is something to keep in mind, that the innovation happens in step by step. That's the, I would like to give it the final word. And thank you once again, everyone. I look forward to see you in the next event.
Thank you very much, Angelo.
Thank you. And so,
Thank you, guys. Have a good day, good night, good afternoon.
yeah.
It was a great pleasure.
Bye.
See you.
Bye-bye.
Thank you guys.
Bye.
Thank
Bye-bye.
you.
Ciao.
Bye-bye.
Bye.